Welcome to 4.4 number 2. What we're going to be doing is using addition and then kind of working our way into multiplication to get a geometric interpretation of what polynomials can mean. So what we're going to do is we're going to find two algebraic expressions for the area of each figure. Now the area of this blue figure right here can be thought of different ways. Like if we think about this first rectangle right here with length x and width 3, the area is length times width, so 3 times x is 3x. So that piece is 3x. The area of this rectangle with length 2 and width 3, length times width is 6. So we could think of this area as being the sum of these two pieces. So 3x plus 6 is one way to think about the area. Now, this should equal the area of the whole piece. Now notice, if this piece is x and this piece is 2, this total length right here is x plus 2. So we can think about length x plus 2 and width 3. So the length x plus 2, width 3. So these are things. So these things should be equal. And the question is, are they equal? We can always get there by multiplication. That is, we can do distribution. Here, 3 times x, that's going to give us our 3x. 3 times our 2, that's plus 6. This does equal that, so it makes a lot of sense. So we'll look at this next one here as well. Now, this is kind of, it's written out what we're looking at here, but we can think about the same thing here. Like if we look at this rectangle right here, it's got length x, width x, x times x is x squared, so the area of that square is that. Now, if moving to the right, this one right here, length 2, width x, multiply those out, 2 times x is 2x. Here, length x, width 1, 1 times x is x. And then finally this last one, length 2, width 1, 2 times 1 is 2. So the area would be the sum of all of these. Now we combine like terms when we can. So we have our x squared. We have an x plus a 2x, that's going to be plus 3x, and then plus 2. Now this should be the same as if we think about the area of the larger figure, that is, if we have this whole area here. So we can think length x plus 2, width x plus 1. So the question is, are these things actually the same? Well, we're going to get into a little bit of multiplication here. I know we're still in the addition subtraction, but there's a couple different ways that people talk about this. Now, there's an acronym, FOIL. F-O-I-L. And FOIL stands for first, outer, inner, and last. And it tells us how to multiply a binomial times a binomial. Now we have a binomial times a binomial because we have two terms here and two terms here. So this FOIL technique first means we're multiplying the first term times the first term. So this x there, the first term times the first term, x times x is x squared. So we have that. Then outer, we multiply the two outer pieces together. The x on the outside times the 1, so it's plus x. Next we multiply the inner. 2 times x is plus 2x. And then finally we multiply the last, so the last term here times the last term here. Combine our like terms, x and 2x is 3x, so these things are in fact the same. But this is a very geometric interpretation of multiplying polynomials and combining like terms. So hopefully that made sense. See you next time for multiplication.